Composite functions. Given that f of x is x plus 3 and g of x is x squared minus 1, find fg of 2. This means we're firstly putting 2 into g of x and then applying the function f. So if we sub 2 into g of x, this becomes 2 squared minus 1, which is 4 minus 1, which is 3. So now we're getting f of 3. This means putting 3 in instead of x in the f function. So that's 3 plus 3, which is 6. Example 2, g f of negative 1. This time we're putting negative 1 into the f function first. So negative 1 instead of x in x plus 3. So it's negative 1 plus 3, which is 2. So we're getting g of 2. So we're putting 2 instead of x in the x squared minus 1 function. So this becomes 2 squared minus 1, which is 3. Example 3, fg of x. So this time we're getting g of x first. G of x is just x squared minus 1. So it's f of g of x. So we're putting the x squared minus 1 into the f function. So that's x squared minus 1 plus 3. We add 3 to negative 1, we get plus 2. The next one is gf of x. So this time we're putting the function f of x, which is x plus 3, into the g of x function. So this becomes x plus 3 to be squared minus 1. So squaring by the binomial, we square the first term, becomes x squared, multiply the two terms and double it, 6x, and square the last term, becomes plus 3. And we're taking 1 from this. So this becomes x squared plus 6x plus 8. Now the last question is asking for what values of x is fgx, so we've worked this out in yellow here, equal to gfx. That's in green. So if these two terms are equal to each other, what would the x value be? Well, let's write them as being equal. So x squared plus 2 is equal to x squared plus 6x plus 8. So if this is true, we will see that, well, x squared can be subtracted from both sides, giving us, when we take 6 from both sides, we can see that 6x is equal to negative 6. Divide by 6, x is equal to negative 1.